All right, guys, sorry about that. Welcome back. Had a little bit of an interruption, not a big deal. So we left off saying that we didn't finish using all of this information. We used a perpendicular part, but we didn't use the word bisect. And we refresh our memories. I said bisect means cut in half. So we said that AD cuts CE in half. So that means that this guy is congruent to this guy. So that's what we were in the process of writing for step 3. Says that CB is congruent to EB. Again, we want our congruent pieces to stay. Since I want B to be congruent to B, I need to put him second. So then over here, that is the definition of bisect. Now, we've shown that we have our bisect. We've shown that we have right angles, but we haven't proven technically whether or not these right angles exist in my important picture. So I drew them strategically, but did I say exactly that I had right triangles? I can't use the theorem of hypotenuse leg until I show or state in some form that I have right triangles. But because I have a right angle on my step number 4, I can get one step closer to using my HL. I can say triangle ABE and triangle CBD are right triangles. And the reason I can say that is we have that one right angle there. So it's the definition of right triangles. If we didn't have that right angle guy, not only would we not be able to prove this completely, trying to move my words here, there we go, but we also wouldn't be able to do our definition of right triangles. So now that I've said that I've said that they have right triangles clearly has a hypotenuse and it has a leg, so I can use that. And I've got my right angle in there. Step 5 tells me I can say that triangle ABE is congruent to triangle onto A to B, so I need to go D to B to C. Just a smidge more. And I get to do that based on hypotenuse leg theorem, or HL. All right, next one. Again, we're going to try to prove based on hypotenuse leg. And like always, step number 1 is going to be any of my given information, and I'm told that B is the midpoint of AC. And even though I'm told this, I see something else. So let's get my highlighter out. I see these tick marks, and I see these drawn in. I cannot use any of that information until I explicitly state that in my statement columns. So I said that EB is congruent to, we'll go E to B. I'm going to assume that D to B. And here's the reason I can make that assumption that B is going to be equal to B. If you look in your proof statement, it goes B in the same spot as B. So theoretically, when I'm trying to prove it, I'm trying to show that B and B are congruent to each other. So since I have these tick marks already on here, I can state that they are equal in that form. And what else do we know? Angle A and angle C are right angles. Close that a little bit, just because I type all the words out. I'm trying to not shorthand so we understand the concept, so we all agree. Okay. Alrighty, so I have stated that I have a midpoint and I haven't done anything with him yet. So let's go back and mark some stuff. So midpoint meets in the middle, cuts in half. Yeah, that's the next thing I could do. I'm gonna go in order. So midpoint, again, I'm just going down my given statements, trying to figure out which piece I want to play around with first. I see the word midpoint first, so I'm going to talk about midpoint first. Doesn't matter if you don't. No. Can you do it later? Yes, that's just how I like to do it. So if B is the midpoint of AC, that means B sits in the middle. So therefore, AB and CB must be congruent. And his reasoning is definition of midpoint. Now I see that I have right angles. Now because I have right angles, we know that all right angles are equal to each other, right? If one's 90 degrees, the other's 90, they have to be the same. So because of that, I can say that angle A is congruent to angle C. Why? Because they're both right angles. So definition of right angle. Definition, I missed the I there. And then again, since I have a right angle and the right angles are congruent, I can say that I have right triangles. So triangle BEA and triangle BDC are right triangles. Pull this one out a little bit farther. Yeah, I'm not going to run into my face yet. And hit the face. So enter. And that's the definition of right triangles. So therefore, since I talked about having the hypotenuse because they're equal, and I have this leg equal, and I have a right angle, and I have a right triangle, I could say triangle BEA is congruent to triangle BDC. And our reasoning here is hypotenuse leg. Good luck on your homework.